Okay, Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Ya Rabbal Alamin. Okay, so the last lecture we have learned about how first of all what is signal, and then we have learned about how a signal can be operated, such as it can be shifted, can be delayed, can be compressed, can be advanced, can be shifted, alright, and then we can also multiply with a constant multiplier for the operation. Okay, so now we are going to learn about signal classification. Alright, so let's say we have know also that signal is a function of time. So signal also carry informations. Okay, so there are many ways they can be classified. Okay, some of it is the predictability of their behavior. So signals can be random signal or deterministic signal. Okay, so some signal varied with time. Okay, and they also varies the amplitude. Okay, that means that if varies time variable, that signal can be either continuous time or discrete time, alright? And it can also be an analog or discrete in amplitude, or we can have a digital signal or an analog signal. And signal also can be classified with their energy content. Okay, some signals are finite energy or infinite energy. Okay, so if it is a finite energy, it means it's an energy signal, but if it's infinite energy, that is a power signal. Okay, if the signal exhibit a repetitive behavior, that means at certain period they repeats, that means that particular signal is a periodic signal. But if a signal does not repeat or its behavior, such as a noise, it can be random, any signal, so that kind of signal is a periodic signals. Okay, and last but not least, we can say if the signal is symmetry with respect to the time origin. Okay, so if respect to the x-axis or y-axis, or it can be either even or odd signal. All right. Okay, so how about a size of a signal? So we can know that the signal is large, or it has how much strength. Okay, usually we call it a signal strength by the amplitude of that signal. So whether it's high or low amplitude, that varies with time. Okay. So one more, we can consider how long is the signal is available. So it's a kind of the duration of the signal. Okay. So it exists after a certain time, and what is the range of that particular time. All right. So the first classification of a signal here is a signal energy. Okay. So usually, if we want to make a test whether the signal is an energy signal or power signal, we use this equation. So, for example, we have function xt is a signal xt. So we find the area under x squared t, or the integrations at certain range for x squared t dt. Okay. So if it have a finite value, so that particular finite value, so that particular signal is an energy signal. Okay, so there must be a value here. Okay, or we can call it as a area and area under x squared. Okay. Okay, then if it's not an energy signal, then it is a power signal. Okay, so the energy signal must be finite for it to be meaningful measure of the signal size. Okay, a necessary condition for the energy to be finite is that the signal amplitude approaching zero as t approaching infinity. Okay, what does this sentence mean? right? So if the time is approaching infinity, okay, so the amplitude, for example, we have very high amplitude here, and when it approaches infinity, it will goes to 0, okay. So this kind of signal is an energy signal because this area under the function is finite, okay, finite, okay. So it has a value, so it's an energy signal, okay. Otherwise, okay, if the integral will not converge, so that means it looks like this, so it's going to be bigger and bigger, okay. So we cannot define what is the area under this signal when it approaches to infinity, okay. So this kind of signal is called the power signal, okay. In such case, okay, if we found this kind of signal, we must put a time average, like how long we want to measure this signal. Like we put a range from certain time to certain time, okay. So there is a time average. So for the power signal, okay, so the power signal, we can know the time average just now is defined as 1 over t. So to find the p, so it's going to be the same integration of x squared t, just like the energy signal, but it has to be divided at 1 over t. Okay, so if you do this test or operation to the equation and it get value, okay, it has a value finite, so it is a power signal. It must be finite, okay. Alright, finite energy and finite power signal. Okay, so the signal is said to be finite energy or energy signal if the signal is finite and integrable. Okay, so for finite energy, the power is 0. Okay, so if we have energy signal, means the power is 0. Okay, so it has to be finite and integrable, means it can be integrate or we can find the area here. But the signal is said to be finite power. Okay, so this is energy or power signal. If the signal is infinite, it like until forever, okay, cannot be integrated. So this is a power signal. So this energy is infinity. So if power, energy is infinity, but the power is finite, okay. Okay, so this one, the power is 0, right? Note that the signal power is the square of its RMS value. So the P is equivalent to 1 over T integration of the x squared T dt. Okay, the square of its RMS value. So this is the RMS value, root mean square. Okay, for example, we have xt equivalent to 1. Okay, this means it's going to be 1 from 0 to 1. This is 0, this is 1, so it's going to be 1. But the rest of it, it is 0. Okay, so this is 1. So this is xt. So if you look at the signal, it is integrable and finite. Okay, so if we multiply 1 here with 1, okay, so the area under this equation is 1. Okay, so it's an energy signal. Okay, so if an energy signal, when we do the test for power, the answer will be 0. 1 over t integrate functions 1 squared dt. Okay. The next one is x every n equivalent to 4. Okay, how do we plot the signal? So let's say xn equal to 0 is going to be 4. N equivalent to 1 is going to be 4. N equal to 2 is going to be 4. Okay, until n can be infinity. Okay, so if you look at this signal is infinite, like cannot be integrated, exists until forever. Okay, so it's an power signal. Okay, the energy is infinity. Okay, okay, but you can find the power using the formula for these functions. Okay, the function p squared, okay, and divided by n. So n depends on here, okay, function. Okay, so for this, obviously we can find the area under the equation, and when it comes to infinity, the amplitude is 0, so it's an energy signal. Whereas the second signal, we can see that it has the value here until forever, okay, so we cannot integrate it, so it's a power signal, okay. Okay, so let's see these functions, how to find its energy here. Okay, for example, the function is 2e minus t divided by 2. Okay, sorry, not e, but x. Okay, x. Again, 2e minus t divided by 2. Okay. Okay, so from 0 to infinity. Okay. From minus 1 to 0, the function is 1. Yeah, sorry, 2. Here 2. The amplitude is 2. Okay. Okay, so that means we have to integrate two parts. This part 1, and the other part is number 2. Okay. So if you look at these equations, the first part is only 2, okay, but it exists from minus 1 to 0, minus 1 to 0, okay. So it has to be 2. The equation said you have to square, so 2 squared, okay. Plus the second part is from 0 to infinity, 0 to infinity. What is the equations? The equation is 2 e minus t divided by 2. Okay, so you have to square. Okay, so become 4 e minus t dt. Okay, what is the range from 0 to infinity? Okay, so the answer is 8. So that means area under this equation is 4 plus 4 to 8. Okay. Okay, for the second graph, it's like a zigzag, okay, and it goes up till infinity. Okay, so we have to define one period. Okay, one period, because depend on this equation. This equation, yeah, or you can find it one period. Okay, so for one period, how to check the period? It patterns repeat. Okay, so from here minus 1 to 1. Okay, minus 1 to 1. What is the function? Okay, we know that this function is x. Okay, why? Because here is 1. Okay, and here also 1. Okay, so the c here, the m, y equivalent to mx plus c, right? X plus c. So m is equivalent to, you choose one point. What is the y divided by x? Okay, and the c is the point that cross along the 0. Okay, so 1 divided by 1 is 1. So the function only x. When you square, become x squared. Okay, so when you substitute here t, you integrate t3, you put in the t domain, t3 divided by 3. Okay, from minus 1 to 1. Okay, so at one period, okay, so it has the values of 1 over 3. Okay, so first of all, you can see the shape of the signal, and the second one, you do the test to find the values. Okay, so now you can identify this is energy and this is power signal. Okay. Alright. So again, if it's energy signal, there is an area. You can measure the area under the signal or the equation. Okay. And then for the power signal, it ends until infinity, but you can find 1t by using the formula. Okay. So P here is 1 over 1 integrated the function E minus T squared, okay, dt. Okay, so this is the power, so you can find 2, 3, okay, watt, yeah, power in watts. Okay, so next is find the energy and power of xt cos pi t divided by 2 plus pi over 4 from minus infinity to infinity. Okay. The second one is 1 plus j e minus j pi t over 2 from 0 to 10. Okay. Because otherwise is 0, so it does not follow the equations. And the third one is zt equivalent to 1. Only from 0 to 10, okay, otherwise is 0. Okay, so now we do the test. Okay, what is the test saying? For energy, it has to be integration of that signal squared, okay, dt. For power, equivalent to same like in energy, okay, okay. What's 1 over t? Integration of this side is same with energy, x squared t. Okay. So when we test this, okay, first of all, you can substitute the function xt in this equation E. But if you look at the range, okay, cos usually it's like this, okay, and it's from minus infinity to infinity. So obviously it's power, okay, and the energy is infinite, okay, until forever, okay. The second one, it has a closed values, okay, because from 0 to 10, it has these functions E, okay. So you just, whatever the function is, you squared, okay, and then it exists from 0 to 10, okay. So substitute, integrate the squared, integrate, okay, and then from 0 to 10, okay, so get the value of 20, and the zt, so this is yt, this is xt, and then zt is z equivalent to 1 from 0 to 10. Okay, so this is zt. So obviously also is an energy. Okay, it has area under this graph. Okay, alright, so for the power, okay, since this one and this one is energy, so obviously power is 0 for y and z. So now we want to find what is the power values for the function xt. Okay, now we substitute cos squared t into the equations divided by the 1 period, okay? And then you solve this one using a plus b cos squared, okay? So you have to know what is the formula for this one, okay? And then you can find the values of power 0.5 watt, okay? You have to solve this one, okay? Okay, this is an example. Power and energy. Okay. So the first classification is whether the signal is energy signal or a power signal. Okay. So the next classification is whether the signal is a deterministic or random signal. Okay, what is a deterministic? That means that particular signal has a description physical, or we can interpret it in the mathematical form or graphical form. That means we can shape it or draw it or describe it in the mathematical form. But for a random signal, we cannot tell what is these equations. Okay, so it can be anything, sine plus cos or whatever, but we cannot determine its value. Okay, so this is usually values that cannot be predicted. Okay, but it exists in noise, for example. Okay, so this is a sample of a random signal. We cannot describe. For this one, we know that it has one t equal to 20, one period. Okay, one period is 20, and we know its amplitude. Okay, we can know the time as well. For this one, is unreadable. Alright. Okay, so the third classification is whether the signal is a continuous time signal or a discrete time signal. For a continuous time signal, for every time has a value. Okay, even 0.001 we have value. But for discrete, it only specified only for discrete value of time. So for example, just now we have the example xn. Okay, so mean n only at this value, n1, n2, n3, but not mentioned here. We define as 0. Okay. Alright. So the fourth one is whether the signal is analog and digital. For analog signal, the amplitude take on any value in continuous range. Okay, so it looks like the continuous signal as previously. So it has a continuous value. It does not stop. Okay, but for digital signal, and you can see there is a variation of amplitude. Yeah. Okay, the amplitude can take any value. Okay, so many amplitude at this signal, but for digital, only two, either -1 or 1. Okay, so finite number of values, right? Okay, so this is an example for a to D or D to A, analog to digital and digital to analog conversions. So for what you can see here, we can actually convert the analog signal to digital signal by quantize its discretion in time. Okay, so we cut or chunk it in a certain time, like this one is TS, 2TS, 3TS, and then we find the values at the amplitude. So that is how people convert an analog signal to a digital signal. Okay, so they discrete in time and find the amplitude of an analog signal. Okay, so how we decide the parameters of TS to TS is a sampling period, T as sampling period, and we also have this the quantization level, delta. Okay, so not only the amplitude we can read, but we also call this one as delta. Okay, the maximum amplitude, and between this one delta divided by 2, and this one is minus delta. So this is the quantization level. Okay. Okay, so we put one sample. What is the quantization level? Second, what is the quantization level? Into finite numbers of levels, so that each sample is approximated by them, so we can know the values at each sampling time. Okay. Okay, so if you look at the signal, this signal is actually an analog signal. Okay, the first one. The second one is a digital signal. Okay, the third one is the discrete signal, and this one is also discrete but analog, and this one is digital and discrete. Okay. Okay, so the next classifications is whether a signal is periodic or aperiodic. What is periodic? That means the signal has a period. Okay, so what is a period? That means the signal has a values that repeats at certain time. Okay, so after T naught, it will repeat again the same shape of the signal. Okay, but aperiodic does not repeat after a specific interval of time. Means there's nothing that it shows or resemble the previous shape of signal. Okay. So for a periodic signal, so when we define the values from minus infinity to infinity, and we find that there is a values of positive real T naught, okay, we call this period. Like T plus K is the amplifications, like K1, K2, and then every K it will repeats again, it repeats again and again. Okay. Okay, so this is a periodic signal. Okay, so at certain point it will for this one, the purple one, the frequency is F. Okay, the blue one, okay, so this is F. Okay, this one is 1 over of this one, like half of it, 3F. Okay, remember what is F? P is equivalent to 1 over F. Okay, so whatever the time, you have to inverse to get the frequency F, 3F, and 9F. Okay, so this is in time analysis, or you can see this in oscilloscope. Okay, in the frequency domain. Okay, so for the first one is F. Okay, is T equivalent to 1 over F1. Okay, so this is F1. Okay, the second one is 1 over F2. Okay, so this is F2, 3F, and then this is the black one is the 9F, 1 over F3. Okay, the black one, the T3. Okay, so for the aperiodic signal, which looks like this one, if we see the frequency domain, it will looks like this one. Only the amplitude for sine wave of frequency F. Okay, so that means we cannot detect all the frequency, but only at frequency F, which is not repeats. Okay, for this one, it will repeats. Okay, the next one, if we have two combination of signal, okay, say signal X1 and signal X2. Okay, how do we define the fundamental period? How do we agree the period or the fundamental between these two? Okay, so let's say GT is an X1 multiplied by A, and also plus B multiplied by X2. Okay, so how do we find the fundamental period? Is we have to identify what is the period of X1, which is T1, and what is the period of T2, which is from the function X2. Okay, and then we divide T1 divided by 2, and if it's equal to a rational number, meaning that a number that can be divide, like no values after that, like 0.1, okay, for example. So the minimum value of t that for this function gt is called the fundamental period, okay. So how to find the fundamental period? So you have to multiply n with t1 and m, or either m multiplied by t2. Okay, so this equivalent to fundamental period. Okay, that equivalent to this GT. So the fundamental period of GT. Okay, let's see an example. So G1 is a combination of 3 sine 4 pi t plus 7 cos 3 pi t. So this 2 is x1 and this is x2. Okay, so let's find the period t1 for x1. Okay, so how to find the period? You have to consider inside the sign. So inside the sign is 4 pi t, which is, if we rewrite in a general form, is equivalent to sine omega t. Okay, sine omega t is equivalent to 2 omega equivalent to pi f. Okay, now we want to find the f, right? Or f equivalent to 1 over t1. Okay. Pi divided by T1 or 2 pi f, yes, equivalent, okay. So equivalent to 4 pi. So when you rearrange this one, T1 divided by 1 over 2. Okay, so the period of x1 is 1 over 2. But for omega 2, what is omega 2? Here is omega 2. Okay, so 3 pi. So 2 pi divided by T2, which is equivalent to omega, equals to 3 pi. So T2, you relocated, divided by 2 over 3. Okay. So let's divide 1 over 2 divided by 2 over 3. Divided means we multiply, we change, right? So will become 3 multiplied by 4. Okay, 3 multiplied by 4. So what is the fundamental period of this function? Okay, so you have to multiply m with 4 and this one with n. Okay. So now let's multiply 4 and t1 equivalent to here. So 3 multiply by 2 over 3. So 2 second. Second is fundamental period. FT, fundamental period is T, and N multiplied by 2, 1 over 2. Okay, so 2 second. It should be the same, this one. So 2 second is the fundamental period of G1. Equivalent to T. Yeah? Okay, if you look at this example, both have pi. But for this example, this is omega 2 pi and this is omega equivalent to 10. Okay, so when omega equivalent to 4 pi, the T1 equivalent to 1 over 2 and omega 2 equivalent to pi over 5. Okay. Okay, when we divided by T1 and T2, so this is T1, this is T2. we found that there is a pi. So pi means 3.142 ... So it's not a rational number. So it's an aperiodic signal. Okay. So if we plot the signal in MATLAB, for example, in this example, this is the first example which is a periodic signal, and this is aperiodic signal. Okay. Okay, so this one we have covered how to find an energy and power signal. Okay, so the next classification is the causal or anti-causal. Okay, so for what is causal signal? Causal means it exists for the time t larger than 0. Okay, for t less than 0, the function is 0. Okay, 0 here. But anti-causal, there is a value for t less than 0, but t larger than 0, it has the value of 0. Okay, so that is, so if the function exists at t larger than 0, okay, so it's a causal signal. But if it exists at t less than 0, so it's an anti-causal signal. Okay. Alright, so the next classification is the left-sided and right-sided. Okay, if you see this function, there is nothing at right side, so it only have left side, so we call it left-sided. And for this one is right-sided. Okay. Alright, so I will stop until there. So inshallah, I will continue how to represent a signal, or how to we model a signal. Okay, how to define a signal. Okay, so that's all. Thank you very much. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.